In the last chapter, we had seen mechanical properties of solids and the different elastic moduli and calculations, stress, strain we had seen. Now, this chapter we shall see the mechanical properties of fluids and the difference between the solids and liquids. You can also observe how the properties are changed. Basically, we will see liquids and gases. There is a common property in both of them. A common property, what they do, they can flow actually. Liquid can flow and gas can flow. So they are called as fluids. They are called as fluids. Basically, fluids are everywhere. So earth is a completely envelope of, not completely, it is a two-third, 66 approximately, of earth covered by fluid, right? Now it's water like is a basic our existence to our livelihood. Without water you can imagine how it can be. So every mammalian body consists of water, consists of water. And the all the process living occurring in living beings including plants, they are mostly mediated by the fluids. So the understanding of the properties of fluid is important here. We shall see one by one properties of fluids. Now what is the main difference between solid and fluid? Solid and fluid. So solid has particularly a definite shape on its own shape. Until unless you apply the force, the shape might be changed, right? Now liquids is also having shape, but it has container shape. If you pour the liquid in the container, it gets container shape. Of course it has also proper shape, whereas gas would not have a proper shape. It occupies entire volume of the container. It occupies entire volume, it spreads over it, it diffuses over it, right? In these have been already learned in the previous classes actually. So the volume of the solid or liquid, gas depends on gas depends on, what is that? It is on stress or pressure which is acted on. Stress, I am using Newton, which is mostly important, and we'll see the pressure of the fluid, pressure acting on it. Basically when we talk about liquid or fluid, mainly we observe that atmospheric pressure or simply pressure. Suppose if you pour the water and place it in open environment, you can think of that there is a atmospheric pressure is acting. So atmosphere has pressure which is acting. Generally, one atmospheric is equal to 1.015 into 10 power 5 Pascal, or Pascal, you know that, which is Newton per meter square, right? We shall see the concept of pressure and the gauge pressure, absolute pressure. What is the total pressure? If a body goes to the bottom of the container, how the pressure varies, how the pressure varies with the depth. We shall all see that. Let us try to understand what is a pressure. Of course, pressure is acting on the body so that as goes on, depth is pressure is increased. That's the general terms. But in a simple way, we understand it. Generally, we go to hospital to get injected injection. See that when a small a small needle or when it is being pressed to our hand skin, suppose a less amount of the force only can be applied, but the contact area is very less. Contact area is very less. What happens? Our skin pierces, right? And you consider a spoon, a normal spoon. You apply the same amount of the force, or you can increase the force, no issue. But what happened? This is a simple spoon. When the spoon is being pressed with a hand or skin, how do you feel? When needle presses are forcefully pressed to the skin, what happens? If you apply with the same forces, what is the effect? Definitely you agree that this effect is more. The effect is more, right? And suppose uh, generally, if an elephant presses with his or her leg on our ribs, what happens? Definitely our ribs would be broken into parts. Generally in the circus, what they do, they take a long wooden plank, and they are allowed to keep the heavy weights on the either side of it, so that his ribs would not be broken and he will take care it. What do you understand this one? There are two things to be understood here. One is a force, other one is area. Area of the contact is important and applied force is important. So both would indicate that some physical quantity which is called as pressure, which is called as pressure. What is that? Less area, more impact. Heavy area, less impact. This is simply understood that which is called as a pressure. So F is equals to, sorry, F by A is equals to pressure. Force acting per unit area is called as pressure. Newton per meter square, which is Pascal. So in generally in the atmosphere, at outside, it is a mixture of gases, where air is there which is also mixture of gas. So general the pressure which is acting on the body, if you keep it outside, what's called as atmospheric pressure. So we also called as the units of the pressure is atmosphere. An atmosphere is also there. Pascal, Newton per meter square. Of course, you can write dyne per centimeter square also. Right? Now let us see in a simple. So we consider when a simple object is submerged in the water. So this is the water where this is a fluid at rest. Fluid in a static condition. Right. So you can consider this simple a body which is submerged. Right. Now what happens? This fluid will exert the force normal to the surface of the body. So force exerted by the body on the fluid, sorry, by exerted by the fluid on the body is normal to the surface. Normal to the surface. Always it is. Think of, imagine if the force is tangential to this one. If the force is tangential to the surface, what happens? Generally, the force cannot be parallel to the surface exerted by the liquid, right? This is simply consequence of Newton's third law. If force is parallel to the surface is there, it will cause the fluid to flow. When such like forces, which is this is tangential to the surface like that, what happens? Surface, the fluid cause to flow. Our fluid will flow. So this is not happened because the fluid is at rest. So only the forces which are there perpendicular to the surface only. See the simple example which is used to measure the pressure. So this is a spring is there, the piston is there, this is the area and force which is exerted on it. This is a idealized form of measuring device. It consisting of evacuated chamber with a spring which is calibrated to measure the force which is acting on the piston. The device is placed inside the fluid. The inward force exerted by the fluid on the piston is balanced by the outward force, spring force, and thereby measured. Inward force as well as spring force. This is a spring force, right? If F is the magnitude of the average force, let us say normal force, then average pressure P average is equal to F by A, right? Now in principle the piston area can be made arbitrarily very small, chosen to be small. The pressure then defined as a limiting sense P is equal to limit delta A approaches to 0 delta F by delta A. Right. Now, what is the pressure quantity? Is that pressure is vector or scalar? Purely pressure is scalar. Don't think it is a vector. Is scalar quantity, right? It appears to be vector where we have seen that this is a direction of the force and force per area. You can think of it as a vector, but it's a wrong thing. There are many directions of the forces are there. There are many directions of pressure to be taken. So direction to pressure is called as wrong. Okay, is a scalar quantity. Already said that Newton per meter square. What is the dimension formula? mlt power minus 2 by L square. ml power minus 2 t power minus 2. So this is uh, pressure. The units of pressure is named as Pascal on the honor of a French scientist Blaise Pascal, who carried the research studies and fluid pressure. A common point where you can observe that at sea level, from the surface of the sea level, the atmospheric pressure can be seen approximately. This is 1 atmosphere is equal to 1.013 into 10 power 5 Pascal. For some textbooks refer 1.015, but the standard form is 1 atmosphere is 1.013 10 power 5 Pascal. Right. Another important thing of the fluid to be studied as density of the fluid. Density of the fluid. A mass of the fluid considered a volume of the fluid, then rho is equal to mass by volume. The units of this one is kg per meter cube. Right. So the density is being always positive quantity. Don't take it as negative quantity, and pressure is always positive. Negative pressure cannot be considered. Similarly, negative density cannot be considered. And dimension formula ml power minus 3. Right? A fluid is largely incompressible. Largely incompressible. Almost the density can be constant. So, incompressible fluids of largely the density can be nearly almost constant at all pressures of the gases, right? And the variation of densities lead to a pressure also. Density and what is the meaning of relative density? Let's see here. Relative density of this substance. How it can be? So, which is relative density is density of the substance by density of the water at 4 degree centigrade, right? Which it is called a scalar quantity. It is called as scalar quantity, right? Suppose the relative density of aluminium is 2.7. Then what is the density of the substance? Density of the substance is 2.7 into 10 power 3 kg per meter cube, right? This is a simple. What is the density of the water at 4 degrees centigrade? Most of the times we had already seen density of the water at 4 degrees centigrade is 1000 kg per meter cube, or 1.0 into 10 power 3 kg per meter cube. So this is a density. Let's see one simple problem, then we'll come to understand what is the simple problem to calculate the pressure. See, the two thigh bones are there. Each of thigh bone cross section area 10 centimeters square. So you can write each of area is 10 centimeters square. Right? There are two thigh bones. Two thigh bones are there. So total area which where force can be acted on it is 20 centimeters square. Now area is equal to 20 into 10 power minus 4 meters square. Mass of the person, mass of human body, which is 40 kg, right? Now weight of the human body is equal to 40 into 10, because F is equal to mg. So 400 newtons, right? Now pressure is equal to average pressure called force per area. Force is 400 newtons. Area is 20 into 10 power minus 4. Or it is 2 into 10 power minus 3. It becomes 10 power minus 3 becomes plus 3. 10 power 5. 2 into 10 power 5. You can write Newton per meter square. This is a simple calculation of pressure.